channel, and here we are going to be working on this problem, and this is question 3 of this year 2025 Waec technical drawing examination questions. Okay, as we have here, we had our figure 3 shows two intersecting cylinders of unequal diameters. Then here we are to draw question A, giving views, question B, curve of interpenetration, and question C, development of the pipe M making XX as seam. Alright, so we have the plan and then we have the front elevation. Okay, so let's talk about the dimensions on the front elevation. So the diameter of the circular base of the vertical cylinder is 50 millimeters. The height of the vertical cylinder is 80 millimeters. And then, so for us to draw this center line of the intersecting cylinder, we have to take a measurement of 10 millimeters from here up here. And then we have that the length from here to here is 65 millimeters. Diameter of the intersecting cylinder is 35 millimeters. Then we have this line to be at an angle 45 degrees to the vertical line. So the same applies to this line and also this center line. Alright, so in the plan, there's a particular dimension that's supposed to be shown. I think that will be an omission on the side of the person that said this question. So because if you look at what we have here, so we have the center line of the circle to be away, or the center line of the intersecting cylinder is away from the center line of the circle. So this is an offset intersection. Okay, so I'm going to take distance from the center line of the circle and the center line of the intersecting cylinder. I will take it as 8 millimeters. So that's what I'm going to do, because I've seen a question like this before in engineering drawing 2 by Pickup and Packer. Alright, so let's go and work this out. So the first thing that we are going to do is for us to draw a vertical center line. So you can start with horizontal center line, but I'm starting with a vertical center line. Okay. Alright, so then I will come up here and draw a horizontal center line for the circle. So it goes like this. Alright, so the diameter of the circular base of the vertical cylinder is 50 millimeters. So the radius is 25. I will take a measurement of 25 millimeters here. Then, so putting a pinpoint of the compass at this point, I will draw a circle, and the circle goes like this. Alright, so we have the circle here right now. So the next thing that I'm going to do is that I need to extend this line. So I will extend the center line just to bring it down a bit. Alright, the next thing that I'm going to do is that I will come down. So I come down, I need a space. So between the plan and the front elevation. So I'm going to draw a horizontal line here. So from this point on the horizontal line, from this point here, I will take a measurement of 80 millimeters down, because the height of the vertical cylinder is 80 millimeters. So this is 80 millimeters. Then here I'm going to draw a horizontal line like this. Then with my set square, so with my set square, this set at this point on the circle, so I'm going to draw a vertical line down here. Then coming to this side, I will also draw a vertical line from this point down. Okay, so we have this. So the next thing that I'm going to do is that, so to draw the front elevation of intersecting cylinder, I will come to this center line here. From this point here, I will take a measurement of 10 millimeters up. So this is 10 millimeters. So at this point, so I'm going to draw a short horizontal center line. Then with the 45 degrees set square to be set at this point here, so I'm going to draw the center line of the intersecting cylinder, and it goes like this. Okay, then the next thing that I'm going to do is that I'm going to extend this a bit. So let me extend it a little bit. So with the same 45 degrees set square to be set on this line, so I will draw a center line at an angle 45 degree. So this line is at angle 90 degree to this center line. This center line is at angle 90 degree to this center line, because we use 45 degrees set square to draw this, and we also use 45 degrees set square to draw this. So as a result of that, 45 plus 45 will give us 90. So the angle between this center line and this center line is 90 degrees. So let's take note of that. So next thing that we are going to do is that, as we have that the diameter of the intersecting cylinder is 35 millimeters. So if it divided 35 by 2, that will give us 37.5. Sorry, 17.5. I'm sorry for that. 17.5 millimeters. So take a measurement of 17.5 millimeters with the compass, 17.5 with the compass on the ruler. So this is 17.5. Put the pinpoint at this point here. So then draw a semicircle like this. Draw a semicircle. Then we divide this semicircle into 6 equal parts. So this is 1. Then here we have this to be so this is 2. Okay, then we have 3 here, then 4 at this point. This is 0.5 and this is 0.6 here. Alright, so we have this. So we have divided into 6 equal parts. So I'm going to number this point on the semicircle. So I'll call this point, this is 0.0, this is 0.1, this is 0.2, and this is 0.3. Then this point will be 2, this is 1, and this is 0. So let's take note of that. So the next thing that I'm going to do is that with the same 45 degrees set square, I'm going to transfer this point so to touch this side of the vertical cylinder. So then from point 1, I will also draw a line at angle 45 degree, and from point 2, I will draw a line at 45 degree. So this goes into the cylinder. So let this enter into it a bit. Then coming to this point 2 here. Okay, so we have already drawn that of 3 as the center line. So draw this into the cylinder. And then, so from point 1, also draw this into the cylinder. Then coming to point 0 here, so draw this into the cylinder. Alright, so we leave this for now. So later we'll come back to the next thing that we are going to do. Before I go for that, so we have that the length from this point is 65 millimeters. So let me take that measurement of 65. Very, very important because of what we are going to use it for. So 65 millimeters from this point. This is 65 millimeters. So I will take my 45 degrees set square. Then I will draw this line. So I'll draw this line here like this. Alright, so let's leave this for now. Then we also need to draw the plan for the penetrating cylinder here. So we need to do that. So what we have to do now is that we take the ruler. So the center of the penetrating cylinder is 8 millimeters down this center. So we take 8 millimeters down from here. So this is 8 millimeters. And we are going to draw a horizontal center line. So we draw a horizontal center line from here. So it goes like this. Alright, so we have this now. Okay. So then, so with my set square, I'm going to draw. So move away from here. So I will draw a vertical center line like this. Alright, so then with the same 17.5 millimeters that we took then, so 17.5 millimeters that we took then as the radius of the intersecting cylinder. So this 17.5, so we put at this point here. Then we draw a semicircle. So semicircle goes like this. Okay, so this semicircle we are going to divide into 6 equal parts as we did for this one. So here we have this point. We are putting it here. So we draw an arc here. We draw an arc on this side. We are putting it at this point here. So we draw an arc here. Then I'm going to number this point. So this point here. So this point now will now be point. This point will be point 0. Okay, so this will be point 1. So you alternate the numbering. This is point 1, this is point 2, and this is point 3. So this is point 1, this is point 2, and this is point 3. So take note of the numbering that we have here. Now, having done this, the next thing that we are going to do is that, so from this point, so we draw the horizontal line. So from here, so draw horizontal line from here to touch the circle, and from this point, so we draw horizontal line to touch the circle, and then from this point here, that is point 1, so we draw horizontal line touching the circle, and then we come up here. Okay, so we draw horizontal line touching the circle, then to point 2, so we draw horizontal line touching the circle, and then from point 3, so we draw horizontal line touching the circle. Alright, so we have this now. So the next thing that we are going to do is that when we are looking at the plan, or when we are looking at this interpenetrating cylinder or intersecting cylinder from the top, we are going to see a circle around this part here. So that circle has to be drawn in the plan. Okay, so we need to show that, how it will look in the plan. So we have to show that, and to do that, this is what we are going to do. So with the set square, we come to this point and we draw a vertical line from this point here. Draw a vertical line. Then coming to this point, draw a vertical line. Then come to this point here, so draw a vertical line. Then we come to this point here, so we also draw a vertical line up here. Then coming to this point, we draw a vertical line. Then we come to this point, we also draw a vertical line. And then from this point, we draw a vertical line like this. Alright, so the next thing that we are going to do is that we are going to look for the point of intersection of the vertical lines based on the numbering that we did here, and also the horizontal lines based on the numbering that we did here. Let's look at it. Now let's start with 0. So this is line 0 here, and we also have 0 here. So this line 0 and this vertical line 0 and this horizontal line 0, they intersect at this point. And we also have another 0 here. So let's take note of that. After that, vertical line 1 and horizontal line 1, they intersect at this point. We also have one up here. So we have one on this side, and we also have one here. The vertical line 2, horizontal line 2, they intersect at this point here. We also have 2 on this side. We have 2 up here, and we also have 2 on this side. And lastly, vertical line 3 and horizontal line 3 intersect at this point, and they also intersect at this point. So we are going to use the French curve to join this point together to obtain the form of this circle that we have here. So what it will form, as we are looking at it from the top, is what we are going to see here. So I'm going to use the French curve to join this together. Then I will pause the video and I will come back when I'm done. Alright, so this is what it formed here. So then the next thing that we are going to do is that from this point, so make this line a thick line from here to here, and then we also make this line a thick line from here to here. Alright, so then coming to the front elevation, we are going to make this line a thick line from here to here. Then coming here, so from this point to this point, make this line a thick line, and from here down, make this a thick line. So this line also, we make it a thick line from here to this end, and then we also make this one a thick line from here to this end. Then for the intersecting cylinder, so we also make this a thick line from here to here. Then we make this a thick line from here to here, like this. And this line, we also make it a thick line from here to this end here. Alright, so now the next thing that we are going to do is to draw the curve of interpenetration. That is question B of the question. Alright, so to do that, now there are two things that is happening here. If you look at this part here from this point 1 to point 2 to point 3, so is on the other side. If you have the solid view of the object before you, you see that this part here you cannot see it. So we are going to show it in the front elevation, and this part from this point here, from this point 0 down, so we can see the curve of that part. So we are also going to show it in the plan. So let's start with this one that is hidden from us. So from this point 1, so look at this point 1 here. So if I'm to draw a vertical line from point 1, it will intersect this line that we drew from here. So they will be at the same point. So this is it. So they will be at the same point like this. So this vertical line that we have drawn from this line 1 here, it intersects line 1. It intersects at this point. Okay, and we also have one here. It intersects it at this point here. Then again, so we draw for 2. So we come to this point 2 here. This is point 2 where the line 2 touches the circle. So draw a vertical line from here down. Okay, so at this point, so here we have, but this is line 2. So intersect it here. So we also have line 2 at this point. So it intersects it here. And lastly is line 3, the point 3 up here. So we are taking it from 1 to 2 to 3. So then if we draw a vertical line from that point 3, so it comes down like this. Alright, so it intersects 3. So where do we have 3? So this is where we have 3, so it intersects it at this point here. So we are going to use the French curve to join this together, but it will be drawn with short dashes line because that part is hidden from us. So it goes like this. So make it short dashes like this. Okay, so we need to adjust this. So it goes like this. And then so we join it with 0 here. So this is how it should be. So the next one is the part that you can see, which is from this point 0 down. So we already have point 0 here, so which is already drawn. So the next one that we are going to do is to take it from 1. So we come to this point. This is where we have 1, this line 1. So draw a vertical line. So draw it down here. So it intersects 1 at this point here. It intersects 1 at this point, and it also intersects 1 at this point. Next is that of 2. So draw a vertical line down from 2 like this. So it intersects 2 at this point, and it also intersects 2 at this point here. Okay, so it intersects 2 at this point. Then we have already drawn a vertical line from 3, so which is this point here. So we are going to join this point together. So we can see this part. We are going to make it visible. So it goes like this. So join this together like this. Okay, then so we join this together. Okay, and then so coming here, so we are going to join this together. So this is almost like a straight line. Okay, so we reduce the curve here. So we join this together like this. Alright, so we have drawn the curve of intersection. Alright, so the next thing that we are going to do is to draw the development of pipe M. So this is pipe M here. Okay, then we have the seam XX here. So this is seam XX. So we can also take it as this point. So this is XX. So this is the plan of pipe M. Now, so the first that we are going to do for the surface development is for us to, so I'm going to make use of this space that we have here. So I'm going to draw a horizontal line. So here I will draw a horizontal line. Then I'm going to draw a vertical line. This point. Okay, then if we are cutting it from here, so this is point 3 here, but before that I'm going to do something so that we can, okay, so I'm going to renumber this. So I'm going to take this point as point 0. Okay, so for the development, this is point 1, this is point 2, this is point 3, and this is point 4, this is point 5, and this is point 6. Then I will go around like this. So we have 7, this is 8, so this is point 8, this is point 9, this is 10, this is 11. Then we're back to 0. So that's how we are going to do it. So we are cutting it from 0 here, okay, which is this point. But I will make use of the dimensions in the plan. Okay, so here we have, this is point 0 now. So we calculate the circumference of the circular base of this pipe. So the circumference has been calculated, that is 3.142 times 17.5, and that will give us approximately 110. Okay, so I'm going to take a measurement of 110 on this line. So this is 110, which is equivalent to 11 centimeters. So this is 110. Okay, so this 110 I'm going to divide into 12 equal parts. Okay, so I'll divide it into 12 equal parts. So this is it. So we draw this line. So I'm going to pause the video and do this division, then I'll come back and you see what we have done and what we have to do next. Alright, so I've divided the line into 12 equal parts. This part will also be 0. Then after 0 we have what? We have 1, 11, then followed by 2, 10, then followed by 3, 9, and followed by 4, 8. Then next we have what? We have 5, 7, then we have what? We have 6. So this is 6 here. Alright, so the next thing that we are going to do after the numbering is that we are going to erect a vertical line on each of these points. So we erect a vertical line on each point. So it goes like this. Alright, so we have drawn the vertical lines. Alright, the next thing that we are going to do is to transfer some distances from here to here. So I'm making use of this. Because so it is easier to take the measurement here than take it here. That is for me. So someone else may be able to do it using this one. Okay, so now we are taking the measurement from this point, from this line here. From this line here forward. So if I'm to start with that of 0, so I put a big point here at this point. Okay, at this point on this line, not on the curve, not on this curve, on this line here that goes from here. So from this point, this line is 0, the last 0 here. So not this one, but this last one here. So we are taking that distance. So for 0, we take it from here to here. So to this point on the circle, so we take it like this. Okay, so we take it like this. Then we put it at this point 0 here, and we make an arc here on 0. So we put at this point, You also make an arc on 0. Then next is for 111. So from this point here, extend it to this point. So here we have it here like this. Okay, then we put it on 1. So make an arc here on 1, and we make an arc here on 11. Next is that of 210. So put at this point. So extend it. This is where we have 210. So put it at this point. So put it at 2 here. Make an arc here and put it at 10 here. Make an arc here. So next we have that of, this is 3 and 9. So from this point here, so extend it to this point. Extend to this point. Then put it at 3. So make an arc here. Then we put it at 9. So make an arc here. Next is that of 4, 8. So from this point, extend it to this point for 4 and 8. So we have this point. So put it at 4. So make an arc here. And put it at 8. So make an arc here. So next, to this point for 5 and 7. So extend to this point on the circle. And take this distance, put it at 5. So make an arc here, and then put it at 7. So we make an arc here. And lastly, from this point here for 6. So extend to this point here. So take this distance, put it at 6, and then we make an arc here. Alright, so we have all this. So all these points are to be joined together with the use of a French curve. Okay. Alright, so I will take my French curve and do that. So we need to look at how the shape goes, okay, or how the points are arranged. So very, very important. So we draw this, join this together. Then, so I come here like this, and then I will join, so these 3 points, I will join them together like this. Okay, so then, so going this way, so I'm going to think for this one, I also need to set like this. Then I will join this together. Then going this way, so I need to make use of this to join these 2 points together like this. Okay, then so also from here, so I will join these 2 points together with this curve. So it goes like this. Then so coming here like this. So I need to join this point together. Alright, so so we have this. So next, so this point, so I'm going to join this point together. I will join this together. And lastly, so for this one, I will join this together like this. Alright, so we have completed that. The next that we are going to do is that, so make this line a thick line like this. And we also make this line a thick line here. And lastly, so this line, make it a thick line. Alright, so this is the surface development. So it's as simple as I've done it here. All you have to do is to practice. Thank you, keep on practicing, and God bless you.